seems to be going. Okay, Sanjeev, take it away.
Okay, so we'll have a fairly short sort of demo and discussion around multi-cluster network policy. Um, the context is that a couple of things, right? I don't have too many slides. I might just show the one slide, but and then we'll do a demo. The context is that there's been input from different directions about the need. We're talking about multi-cluster services. So the logical question is, what about multi-cluster network policy? So you can look at it. You can approach that in a couple of different ways. One is, how far can you go with existing network policy, and is that enough? Or with some modification, can existing network policy work? And the other one is, what are the use cases for different multi-cluster policy scenarios, right? Um, to be honest, there aren't very clear requirements. Okay, um, what I have seen so far is based on some white papers and some discussions with one or two solution architects. But I think in order for this to become official, one has to have a clear set of use cases that are the most important ones, based on customer feedback. Um, so I'm hoping one of the outcomes is we can talk to Brad about proper use cases in order to take this to an official feature status. Um, there was one customer that I did get a chance to speak to, and the impression given there was, it's very important to have some sort of multi-cluster network policy in order to go to production. Some of the Submariner trials, they were saying, okay, yeah, we are getting comfortable with Submariner, but in order to go to production, we need policies. Um, okay, so that was one piece of input. Um, the second, and so I want to keep this as an open thing. Have you all come across use cases and requirements for multi-cluster network policies that you might want to share? Any quick thoughts?
I think it just makes sense as a complementary service on top of Submariner, right? Like we offer service discovery, which you could run without Lighthouse, but it would be more difficult. So you could use like local network policies with CIDR blocks, but it will be much more difficult to maintain, especially at scale. So I think like what we want to give is ease of use, right, with these network policies.
Yeah, but what? So that's fair enough. But also, it would be good to identify specific scenarios that need to be having a policy that can address that scenario. So hopefully, we can get a proper set of use cases to target. So what
Yes,
I
if I may interrupt, I think one interesting one, which I heard mentioned a lot, which might be a good fit for network policies and not necessarily connectivity, which is like blocking certain, like if you have client-server topologies across multiple clusters, then you want to have clients talk to the server, but the clients shouldn't be able to like talk to each other or something like that. I think that's
Right.
an interesting use case, at least for the network policy aspect.
Okay. So let me share one particular picture of a use case which can be addressed by the demo that we'll then see. Um, hang on. Oops, sorry. Um, oops, I should have been prepared with this slide. Hang on. Okay. All right. Let me go ahead and share. Okay. Okay. Can you all see the screen?
Yeah.
Okay. So the one use case that I heard from a couple of people was that. Um, so first, let's look at this. The network policies can be sort of two buckets. One is control plane centric network policies, right, which do things like controlling um, where services are allowed to get imported and exported in the control plane, right? And and one is regardless of what happens in the control plane, even if you have decided to limit your imports and exports, you still need limits in the data planes because you don't want pods to discover exported and imported services, by just probing around and then sending traffic to uh, VIPs, regardless of what happens in the control plane. So this is an example of a data plane network policy. So the use case here is that a multi-cluster service, which we are showing here as MCS foo, is exported by this cluster across some network into this other cluster here, right? Um, but we do not want all pods on this cluster to be able to access this imported service. So, for example, we want pod 2 to be able to access this imported service, but we do not want pod 1 to be able to access to this imported service. So this use case is fairly clear and makes sense. So this would be at least one of the use cases that probably would be needed by many customers, which is limit who can talk to an imported service. Okay, and so this is what we prototyped, and I'll show a quick demo. And here you can see that, so in our particular case, so now this is showing a generic MCS picture. It might be Submariner, it might be any implementation of MCS. Some implementations of MCS don't even have like gateways. So the goal would be to do this in a manner that is as usable for any implementation of MCS, not necessarily Submariner. But if Submariner adds there's some functionality that is unique to Submariner that adds value to the customer, sure, we can do that as well. And similarly, it should be independent of the CNI. Um, it should ideally work for any CNI or at least a large number of CNIs, right? So a couple of quick thoughts here. So I have initiated a draft in the upstream SIG multi-cluster and SIG network and SIG policy, and I can add a pointer to that later. And there was early feedback on it. I hope to bring it up again upstream in the next meeting. Actually, the next meeting is tomorrow, so we'll see how the upstream community feels about it. The general feedback I've got so far is that there are folks, including in Google and others, that do want to have a multi-cluster network policy, and I'll comment more on what the feedback on it is. So let's look at this use case and let's kind of look at a sample implementation. Okay, so hopefully the use case is clear. We want to have some pods access an imported service and some other pods not be able to access. Okay, so now let's look at a demo for that. Uh, any questions on the use case?
I I have one question, which is, as you said, like the fact that something is exported or import, like a service is exported or imported or not, doesn't mean we don't need like the network policies, right? Because we might want to block any unauthorized attempt. So my question is, does it necessarily have to be tied to the export? I guess because as I said, like you could use Submariner and deploy Submariner in a multi-cluster fashion without even using Lighthouse to like, do the service exports, imports, and all of that. But you could still use Submariner and connect to different services on different clusters.
So how common is it to use Submariner without Lighthouse? I would say that actually the reverse might be true. One might want to use Lighthouse without necessarily using Submariner, because Lighthouse represents the upstream standard, right, for service exports and imports. We can debate whether that's an adequate standard, whether service and exports need to be further augmented. They probably do, but at the moment, the MCS is sort of a vendor independent standard, and Lighthouse is the implementation of that. The Submariner gateway is really for providing encrypted tunnels. So, do you know of customers that use Submariner without using Lighthouse, or vice versa?
I'm not aware of any. I'm just saying, like, from a technical perspective, it's not that you have to use Lighthouse. That's what I'm saying. But even if you do use Lighthouse, if you don't export a service, okay, in Lighthouse, or like in Submariner, if you use Lighthouse and use Submariner, but you don't export the service, that service can still be reached via the VIP, right? So that's what I'm saying. It's not necessary to export a service for the reachability. That's my point.
Okay, so I'm again having to adjust my sharing preferences because apparently Chrome has changed the preferences yet again. So hang on a second here, please. Oh. So I could share a tab, but I can't share my screen or a separate window. So let's see. I thought this was fixed recently, but okay. So
Yeah,
I
if you
do.
update it, you might need to like drop and then rejoin.
I see Chrome is already set for sharing right now in my system preferences, but for some reason it doesn't allow me to share either my entire screen or a specific window, only a particular tab within Chrome, and I want to share a different window. Of course. Sorry. If you like, you may want to pause the recording while I search around.
Yeah, I don't think there's an option to pause. I can stop it, but then we can start it again. I think it will be a different one. So we can just edit it, worst case.
Yeah.
It's not for publication of some fancy service. It's fine, I think.
Okay. Yeah.
We're laid back here. No
Somebody
worries.
fast forward through the quiet parts. Okay, Google Chrome is set up for sharing here in my system preferences. Sorry, help me out. This is silly.
Did you change that recently?
No, I changed like a month ago or so when Chrome's defaults was changed, and at that time I
would just try dropping and rejoining
okay, all right. Let me drop and
if
rejoin.
it's set up that way.
Okay, see you in a bit.
Hello again.
You're muted, so
The joys of Apple.
This is a Chrome thing, I think. Chrome plus Apple, that
It's
combo.
Chrome plus Apple for sure. Yeah.
Did that help, or are you still?
Nope. I'm only able to share a particular tab, not this entire screen nor okay, this is back to sharing the tab.
maybe I can try with different browser or something. I don't know.
Okay, fair point.
It's just Apple's way of making making Google a little more painful. can have an open ecosystem, but you're going to have to deal with a little pain. Somebody pointed out to me the other day, though, that you can have almost as much fun with Fedora at times.
It depends on the day, on the
Right.
date, on the alignment of the stars and everything. Like,
When you last upgraded.
actually, I'm on 35, I think. What's the latest? 35, right? Because I got a new laptop recently, so like with the refresh. But yeah, it was fun.
It's a good reminder I need to upgrade. Cat Etsy OS release. Uh-oh.
You're muted, Sanjeev. I don't know if you're.
He's just battling his OS at the moment.
I think he's losing the battle right now.
Yeah.
This is embarrassing and funny at the same time.
Sounds like no better luck with whatever else you switch to.
Firefox is showing some progress, but making me click through various kinds of preferences. So Firefox,
Oh.
let's see.
Might have tried Safari. If you... So I use Chrome.
I usually use Chrome for the Google, for like the chat, like this Meet, whatever it's called. I daily try Firefox, but I found out that if you open video chat too much in Firefox, it tends to cause it to crash for some reason on Fedora. So at least for me, I don't know. It became from tech exchange to tech support meeting.
While we're exchanging fun bug anecdotes, I finally realized my longstanding issue with Docker has to do with the VPN going on and off and resetting some IP route configuration or something like this. But yeah, if you end up running into like in our infrastructure, if you're running our make commands and you have a bunch of clusters running and then you tweak your VPN and then things break, that's what's going on there. But we need to end up moving to Podman and not have these daemons that are so fragile. But I raised an issue for that.
Okay, this time with Safari.
3 for 3.
Third time's the charm.
Manages to go through without. Okay, let's see.
Yeah.
Okay, Safari.
Imagine that.
Okay, so usability still Safari wins again. Okay, Apple, I mean. Okay.
Yeah, big surprise.
Yeah. So this was an illustration of how security comes in the way of usability. I mean, yeah, whatever. Okay, so the setup is the same as the picture that I was showing. Okay, we want to allow some pods access an imported service and some other pods not access the imported service. So on the left here, the window, hopefully you can see it. Is the text large enough to view?
Yeah, it's pretty.
Okay.
Large.
So there's 2 Submariner clusters, and a service has been exported from cluster 2 to cluster 1. And the service has been exported from cluster 2 to cluster 1. And the service has been exported from cluster 2 to cluster 1. And the service has been exported from cluster 2 to cluster 1. And the service has been exported from cluster 2 to cluster 1. And the service has been exported from cluster 2 to cluster 1. And the service has been exported from cluster 2 to cluster 1. And the service has been exported from cluster 2 to cluster 1. And the service has been exported from cluster 2 to cluster 1. And the service has been exported from cluster 2 to cluster 1. And the service has been exported from cluster 2 to cluster 1. And the service has been exported from cluster 2 to cluster 1. And the service has been exported from cluster 2 to cluster 1. And the service has been exported from cluster 2 to cluster 1. And the service has been exported from cluster 2 to cluster 1. And the service has been exported from cluster 2 to cluster 1. And the service has been exported from cluster 2 to cluster 1. And the service has b
You have a typo there. The service imports.
Okay, so it's an Nginx from cluster 2 in the default namespace. So we first look at the CRD that we've created. So I defined a CRD for this and kind of a Golang controller implementation using KubeBuilder. So that was an interesting experience to go through the entire builder KubeBuilder based controller. And I can also share some experiences and some learnings based on that. So if you want to look at the CRD, we see look for the API. So we see that now this cluster has a CRD called Multicluster Policies, right? And for now, I have just created a group called policy.submariner.io, right? And I'll provide the link to the repo later. So a sample policy with that would be something like this. Okay. So this is a multi-cluster policy. The spec is selecting pods that match the label color equals blue. And it's an egress policy. And currently this prototype is sort of an implicit deny. So what it is saying is that the deny is the default action. What it's saying is that deny traffic from pods that match this label when egressing to imported services referred to by this name. Now, because Submariner does not aggregate service imports yet, this implicitly assumes that the namespace into which these services have been imported is the Submariner broker namespace. But once aggregation is fixed, this would be sort of a combination of namespace and imported service, right? So this is basically the sample manifest for the CRD, okay? So pods with this label cannot send to these service imports.
Sanjeev, short question about this. Can't we achieve the same ACL or drop the packet with standard network policy? Because in Submariner, this the destination, the IP of the destination service, we know it already, even in the global net. So we just can define and drop or deny a rule from specific pod to destination IP, isn't it?
So that is true. Okay, so we want to do it in a way that allows service imports to come and go across all your remote clusters without having to change your policy, right?
Mm-hmm.
So that's a fair point. You could do this by basically having a policy egressing to the CIDR of the cluster set VIP. That's what you're saying, right?
Mm-hmm. Yeah. Or specific, destination service IP.
That would require you to have non-global net. So we want this to work for both global net and non-global net, right? So the only IPs, so the actual pod IPs may be duplicated across clusters. Let's go back to the picture here. So we want this to work regardless of whether these pods have IPs duplicated into this cluster.
You're showing your email, not the slide.
Oh, okay. Sorry. Again, the sharing. Hang on. Okay, but I thought I had the sharing to the entire screen.
Yeah, it is. We just, for some reason, saw the email on the slide.
Okay, you're seeing the picture now?
Yeah.
Okay. Yeah. So here, we want this to work even if these pods, have IPs that overlap with these pods, and other clusters that are also exporting the service may or may not have overlapping IPs. But I believe what you're saying is that in all cases, the cluster set IP has to be globally unique. Is that what you're saying?
Yeah, even in global net, we have one-to-one mapping, which unique IP. As far as I know, yeah.
You're referring to the cluster set IP or not, or the gateway IP? You're saying the cluster set IPs are also okay.
The cluster
Yeah,
set IP.
I hear you. So this is let me think about it some more. But this was to kind of create an abstraction that doesn't depend upon, putting down specific IPs, and you have the abstraction of the service import rather than IPs. But you're right that there could be some, ways to work around it by just looking for global IPs. And I'd like
Yeah,
to
also I
think
think this help us to do it in a more Kubernetes way where you can like use the names and based on labels rather than like using the CDUs. Also, I think CDUs, if you use, maybe you'll have to have policy for each cluster or something like that based on what your requirement. But here you can use like the name of the service import also, and like filter it the traffic from multiple cluster all together with one rule also. Just a thought.
yes, but but your point is good that this goes back to the more there are workarounds for these solutions, the more the use case needs to be more precisely defined. If we find that that approach adequately covers the use case, then we may not need a new kind of policy, right? If all the use cases that matter can be addressed by just having CIDR based policies, then we don't need the new CRD. So let's think about it some more. Fair point. Okay. But coming back to the other point, which is how Coast Guard does it. So let's talk about Coast Guard. So Coast Guard is the current prototype for network policy. And what that does is it assumes that it's a non-global net deployment. Okay. Which means that all the pod IPs and all the service IPs are all globally unique. So and there, what it does is it takes existing network policies that are created in one cluster, reflects them to the broker cluster, and translates them to equivalent generated policies for the other clusters, knowing that all the pods have unique IPs. And that's how the current Coast Guard implementation works. The issue with that is that it only works with all pod IPs being globally unique. And so it doesn't support multi-network and global network types of scenarios. And that was sort of the primary motivation for doing it this way, okay, to not have the restriction that Coast Guard does. But if Coast Guard, combined with what you were saying earlier, can solve all the use cases, then that reduces the need for the new policy. Okay. Now, in the upstream community, there are also some additional use cases being discussed that we haven't come to a resolution yet. So we'll have to keep probing on to what are the most appropriate use cases to target. Some of those do have workarounds, like you just said. Okay. So so coming back, assuming this is how we want to do it. So this is this is the CRD that we've created, and so this is our target cluster on the left here. So we have some target pods. So we have these these are the clients. So the blue and the red, and they have the labels attached as we, if you look at. You'll see that the blue pod has the label color equals blue, and the red pods have the label color equals red. So as you recall, the policy distinguishes based on the labels of the pods. So let's first see whether both of these pods, without applying the policy, can access the imported service. So I go into the red pod and I curl the cluster set FQDN. And so we were able to access it, right? And now we go into the blue pods and access the cluster set FQDN, and we can access that as well. So now the service that has been imported is available to all the pods in the importing cluster. So let's now apply the policy. So over here, we're going to apply the policy one that we saw earlier. Okay. And now if we say get multi-cluster policy, we see that sample one policy has just been created in this cluster. Now let's try both those pods again. So let's get into the red pod and curl the service. The red pod can still access it. Let's go into the blue pods. And the blue pod can still access it. Hang on. Whoopsies. Did I do something wrong?
Is it just for me? I don't see anything happening on the screen.
Yeah, me too. I was say that.
Are you seeing the bottom?
I reconnected and I don't see anything, but it was stuck before.
Are you seeing activity on my bottom left terminal?
No.
Okay. Again, is there some sharing issue again? Do you see the terminal windows themselves?
I see, there are three windows, two on the left and one on the right.
But they're like frozen?
Yeah, they're not moving.
Okay.
It seems like it got disconnected because I tried to reconnect to the call and it just says Sanjeev Rampal presentation. I don't see anything. Now I see.
Something just happened there.
It came back when you turned off the sharing. It came back.
This is flaky. You see activity now?
I do.
Okay. All right.
But I missed, like, I don't know about everybody else, but I didn't see anything happening. It was just...
Sure. So what we did was we confirmed that both the pods in the importing cluster could access the imported service. Let's try that again. Actually, something has probably gone wrong with the demo. This has been a jinxed session, so not surprised. Okay, so here from the blue pods, we are accessing the imported service right here. And we are able to access it.
Yeah.
And the red pods, again, we are accessing the cluster set.local service, and it can access it too. So the filter is apparently not working because I had already created the policy. So let's try to debug it just a little bit. So let's actually look at, so what it's actually doing is it's creating IP table rules based on looking at the pods on the selector and the service import data, right? So it's reading whenever a service import is created and the policy is created, it reads those and creates IP table rules. Okay, so let's just see whether those IP table rules have been created.
So it doesn't actually go through the regular network policies. That's what you're saying.
That's right. Yeah, this is completely independent of the current network policy. It is independent of the CNI as well. in theory, I think there could be some issues with some CNIs, but in theory, it's independent of the CNI. And it could be made independent of the MCS implementation as well. Right now, it is dependent because of the service aggregation issue. So this is sort of independent of the CNI, independent of the MCS implementation. It could be for any MCS implementation. And it just assumes that it just assumes that you're running on Linux because it creates IP table rules. We'll talk about that dependency on the CNI later. Okay, so yeah, so the Docker thing. So let's look at okay, so I think I've probably hit a bug here because I was probably trying this last night before running this demo, and that might have messed it up. So what it's supposed to do is that in the forward chain, we create a hook to go to what we call it as an MCS chain. And apparently I don't see that hook added here. And then, so that means all traffic that is getting forwarded by the CNI to the host in order to send to the Submariner gateway is examined by this MCS. And this MCS chain, this one has been set up. So you can see that there is a drop rule set up for sources that are 10.1.19.9 and destination of this, right? So this drop rule has been set up by the controller, and it's looking for sources which are 10.1.1.192.9, which is in fact the blue pod here, right? You can see that this is the source IP, and the destination here is the cluster set VIP, the 100.143.79, 100.143.79. So what it's supposed to be doing is dropping traffic from blue pods to this cluster set. But it is not currently working because it did not add the hook into the forward chain. So is there some way I can, let's see if I can try to jiggle it back into working.
Yeah, just a quick time check. We have a few minutes left, but I think we can continue if you're up.
Okay, so I mean, do you want to just play around on the cluster some more, or just kind of have a bit of a discussion again on where should we go forward from here?
Whatever makes sense to you. I don't know. And just because we have like 2 minutes left, but
Okay.
We can continue like a bit more because
Let's continue just 5 more minutes. We don't want to continue too much more, or maybe, yeah. So, okay, so the bottom line here is that requirements are still not 100% clear. I haven't gotten very clear requirements from Brad. I was hoping either any of you have had these discussions on the requirements. Clearly, the Coast Guard, which you guys have already developed, is one way to solve it without the global net assumption. So the two issues with the Coast Guard are, number one, it requires global IPs everywhere. And number two, it may not be as scalable because it takes every network policy from every cluster and reflect them into every other cluster with modifications. So whenever a pod changes, a pod comes up and down in one cluster, it would have to recalculate all the policies and reflect them to all the clusters, because it's just basically doing pod level IPs based policies across all the clusters. So it's not very scalable, and it doesn't work with global net. So that's the issue with the Coast Guard approach. But it might be fine. And if it turns out that the use cases people care about are all addressable via Coast Guard, then Coast Guard is perfectly usable. Okay. As far as upstream, again, as I said earlier, people are interested in having this, but there's been some ambiguity on use cases, and some debate about whether it should be dependent on the particular MCS implementation, like Submariner or whatever, or it should be generic, just dependent upon MCS, or otherwise. So that's sort of in terms of the use cases and the requirements definition that really needs to be very, very clear before we decide that this needs to be an official feature. As far as the implementation, it was a useful experience to go through, building a controller in KubeBuilder and so on. I learned that the CoreOS IP tables library, that is what I used, which is also what Submariner uses, is not the best library for IP tables manipulation. It's sort of okay for some cases, but it's better if you want to use IP table manipulation in a controller. It's better to do it the way possibly kubeproxy does it. So that's sort of an area of improvement in using the CoreOS IP tables library. The other possibility is to implement this using eBPF rather than IP tables. And that was the original goal, but because it wasn't obvious to me that I'm not familiar enough with libbpf and the other BPF related libraries. So the thought was to first do this implementation with IP tables and then do a second version, a more proper version or a different version with eBPF. So that's another future thing. But really the main next step is being very clear on the use cases, deciding whether those use cases can be met with workarounds based on IP addresses, and then having an implementation possibly based on eBPF. Although in this particular case, it's not obvious to me that the performance with eBPF will be that much better than IP tables. Yeah. Any other thoughts or comments?
Yeah, I think, well, you talked about Coast Guard, and you mentioned it now and previously, but just for the context, Coast Guard was a proof of concept of a naive way to implement like multi-cluster network policy. So it wasn't really built as a solution. It was just an attempt to do something very naive, and it's not necessarily supporting all the use cases. And definitely it doesn't support GlobalNet because it was done way before. And as you can see, Coast Guard even like uses kubefed, which we already dropped a while ago as a synchronization mechanism. So I wouldn't look at Coast Guard as like the standard really and try to derive too much from it. It was just like an approach to try to do something. But I think, yeah, the use cases, as you said, we need to define like the specific ones. I think this work could be interesting in the context of the MCS SIG and the MCS API. And as you said, it sounds like it should be like kind of agnostic to the implementation of how which multi-cluster solution you use, right? Whether you use like a Lighthouse to implement the MCS API or what. But I think, as I said, it's like, to me at least, it seems quite limited in terms of like it really, if it ties into the MCS API, then it's really limited to what's going on with the MCS API. So for example, if we go back to what I said, once you connect clusters using Submariner and you don't have any network policies, then basically any pod can talk to any other pod or any other service, given that it's like it doesn't have to be on GlobalNet. It's different, but if you're excluding GlobalNet, then they can talk to each other, right? In terms of connectivity, if they know the IP, they can try to reach each other. There's nothing blocking that. So there, I think this approach is very limited to what is exported and imported via the MCS API. But maybe customers would want like more fine-grained control. So for example, if I have a spread out cockroach DB, right, which has multiple pods running on multiple clusters, and they need to talk to each other, and I need to expose it like as a service to different pods on those clusters or different clusters, then I don't know how this approach will fit in, right?
So this actually will address that case, because let's say that these pods are the remote cockroach DB pods. You only want the clients of cockroach DB to be accessing that database and not every other pod. So you're importing the cockroach DB.
If the pods themselves are on different clusters, we have seen such a use case, and there's POCs to do that. I don't know if any customers are using it, but there is it's a valid use case for us, at least, that you can stretch your cockroach DB across multiple clusters and like shard it, and cockroach takes care of the sharding, and we take care of the connectivity, right? So then you want those pods to be able to talk to each other across the clusters, right? Necessarily, like if you have network policies in place, then you need to start defining, okay, I want this pod to be able to talk to other pods of the same like cockroach service, or like the same namespace, or I don't know which selector would you use, but necessarily they need to talk to each other, because that's how they sync up and spread the information, right?
Yeah. So again, we don't need to. I mean, we can continue offline if you like, but I do believe that that use case, the cockroach use case, can be addressed. Question is for other use cases beyond that particular scenario. So I mean, one thing to note is that there are two elements here, right? One is that this also introduced the notion of a policy to a service. Today, policies are not between services. Policies are between pods, right? In the current network policy definition. So this is also relevant in terms of introducing service-based policies rather than policies that attach to pod endpoints. And there's also interest in upstream about service and service import based policies, as well as actually one other thing that Google does in their proprietary implementation, right, is that they actually, I do believe, they pass some tags from source cluster to destination cluster. And that's a proprietary Google definition, which they have hinted at wanting to standardize somehow. But not every implementation does that. So for example, in Submariner, we don't pass extra metadata from the source cluster to the destination cluster. If we could do that, and yet have an abstraction that allows you to define a policy. So for example, you can say, have a policy that matches on this tag that is passed, and then you can do some more fine-grained control. So there's some nebulous requirements there, but one does get the impression that there are some folks like Google doing some proprietary things, and how much of that needs to get standardized, that is still something to be discussed. So let's keep the discussion going. Happy to discuss offline. We don't need to drag this call furthermore. So thanks. Sorry, this was sort of a stop and start demo, but the basic idea hopefully was clear, that we defined a CRD for a multi-cluster policy. It addressed the use case shown in this picture. It addressed that by referring to service imports rather than with IP addresses. And we did a prototype implementation using KubeBuilder and using IP tables in the data plane. And potentially that implementation could be redone with eBPF and other technologies. So that's it for now.
It's a good discussion. Probably we should share the slides, you know, to the meetup or whatever. Sanjeev.
Okay.
Thank you.
Oh, you mean the upstream slides or this slide that I'm sharing?
This this slide deck.
Okay.
Thanks.
Okay. Thanks, Sanjeev, for the presentation and the demo.
Thanks. Yeah, but I would want to get your input on use cases and things like that. So let's continue offline.
Yeah, sure.
Thanks.